All right, so in order to practice the concept of power rule, I have another integral for you, which is using P3 concepts, and this will help you to sharpen your skills by a lot for trigonometry especially. So yeah, let's just solve this. And as we can see, we have this trigonometric expression with whole power 2. So let's just expand this quickly, shall we? So I'll just write this as 4 cos squared theta into 1 plus sine theta whole squared. And then just expand this even more. So this will be 4 cos squared theta 1 plus 2 sine theta plus sine squared theta. And yeah, I'll just one more time, expansion needed. I'll just take 4 as common, by the way. So take 4 as common, this will become 4 by 2. And yeah, 1 cos squared theta plus 2 sine theta cos squared theta plus cos squared theta sine squared theta. So yeah, we have to solve this, this, and this. All right. So as far as cos squared theta is concerned, this is a basic integral for P3, and I'm assuming you have the knowledge that we have to substitute this over here, which is 1 plus cos 2 theta divided by 2. And how did I obtain this? I obtained this from the formula cos 2 theta equal to 2 cos squared theta minus 1. Cos 2 theta equal to 2 cos squared theta minus 1. Yeah, I just rearranged this, and yeah, I just substitute this over here in order to solve this part. Now, what about this part over here? How do I solve this? Now, if you recall, this is the same as this over here, which we just learned right now. And how can we use this to solve it? 2 sine theta cos squared theta, was it? Yeah. So 2 sine theta cos squared theta can easily be solved if we just rewrite it like this. 2 cos theta whole squared sine theta, and yeah, this is f of x, which is cos theta, and its derivative is minus sine theta, but we can introduce a minus sign over here and over here. And yeah, now it's really easy to solve this, because the answer will be minus 2 cos 2 plus 1 theta divided by 2 plus 1, which means minus 2 cos cube theta divided by 3. This is how we will solve this middle part here. Now, how about this part here? This is a bit tricky. So for this, what we need to do is we need to be aware of this substitution right here, which is sine 2 theta is equal to 2 sine theta cos theta. Now, this is looking a bit familiar, right? But this is cos squared theta, sine squared theta. Meanwhile, this is sine theta cos theta. So how about I just square both sides like this? Now this will become sine squared 2 theta is equal to 4 sine squared theta cos squared theta. All right, and let's just take 4 over here. So this will become sine squared 2 theta divided by 4 equal to sine squared theta cos squared theta. So yeah, I can substitute this over here, and that's exactly what I'm going to do as well. So 4 by 2 is 2 integral of, and over here I'll substitute this, which is 1 plus cos 2 theta divided by 2. And here I will substitute, I'll just leave this b for now, but we already know the answer for this is what we figured out over here, and it's this right here. Fine, we'll just use this answer because we already computed it. Now 2 sine theta cos squared theta here, and over here we will substitute sine squared 2 theta divided by 4. So yeah, but if you notice, it's still quite difficult to compute this part over here. So what do I do now? Now for this, what you need to be aware of the fact that there is a ratio going on in trigonometry. For example, cos 2 theta equal to let's say 2 cos squared theta minus 1. This is the ratio, right? 2:1 with the angles, if you notice, because this is always twice of this angle. What this means is, if I wrote this as, for example, cos of 4 theta, I will write this as 2 cos squared 2 theta minus 1. This is a property of trigonometry. And if I wrote this as cos of theta is equal to, I can write this as 2 cos squared theta by 2 minus 1, because this is a property of trigonometry you need to know. All right. So following this property of trigonometry, I can clearly state that over here, even though we have sine squared 2 theta, right, we do know the fact that sine theta itself is equal to 1 minus cos 2 theta by 2. This is a substitution all of you must know by now. Even if you don't, let me just show you how it's derived. It's derived like this: cos 2 theta equal to 1 minus 2 sine squared theta. This is a basic thing you know from list MF19. Now let's just rearrange this and we will get 2 sine squared theta equal to 1 minus cos 2 theta, and boom, you just get this when you arrange this. Oh, and by the way, this will be sine squared theta, my bad. And yeah, this is a basic substitution that you all probably should know by now. And we will be using this over here. Now, how will we be using this? Let me just rewrite this. 1 minus cos 2 theta divided by 2 is equal to sine squared theta, right? Now, double to half ratio will be applied here too, because this is a trigonometric expression. It's actually more of a formula. And yeah, 2:1. So if I was to substitute, let's say 2 over here, I would have to substitute 4 over here. And that's exactly what we're going to do. We are going to substitute 2 here, sine squared 2 theta. And since it's 1:2, that means this should be the twice of this, which means this will be cos of 4 theta now. 1 minus cos of 4 theta divided by 2. And this is our expression right here. All right. So we will be substituting this. I know it's a bit tricky, but yeah, practice makes perfect. You need to know. Now I will just write this like this. Let's just write it: 1 plus cos 2 theta divided by 2 plus 2 sine theta cos squared theta plus sine squared 2 theta divided by 4. No, I'll substitute over here. I will write this as 1 minus cos 4 theta divided by 2. Okay, now this is our integral, and now it's really easy to solve. Let's just erase all of this now, and let's just solve our integral, because it's really easy to compute from now. So 2 into 1 by 2 will be written as, theta by 2 plus cos 2 theta by 2 will be written as sine of 2 theta divided by 4. And this is a basic thing that you must know by now, because this is an advanced series of integrals, that cos 2 theta by 2 is in fact sine 2 theta divided by 2 multiplied by 2, because 2 theta's derivative is 2. So yeah, this will be sine 2 theta by 4. This is something basic that I'm assuming you must already know. Now over here we already determined the answer for this, which was minus 2 cos cubed theta by 3. So I'll just write that, minus 2 cos cubed theta by 3. Now over here we will write theta by 2 minus, now integral of cos 4 theta by 2 will be sine 4 theta oh, by the way, over here I forgot to substitute 1 by 4. Okay, so this makes it 1 by 8 minus cos 4 theta by 8. All right, and we will be writing this as theta by 8 minus, all right, so, and cos 4 theta divided by 8, if we compute its integral, it will be sine 4 theta divided by 8 multiplied by 4. So which is sine 4 theta divided by 32. And now that that's done, we will substitute our limit 0 to pi by 2 and solve it for the exact form. So 2 into pi by 2 here and theta by 8. So I'll just write this as pi by 4 plus sine of 2 into pi by 2 is sine of pi, which is 0, minus 2 by 3 cos of pi by 2 is 0, plus pi by 16 over here, minus sine of 2 pi, which is also 0. So yeah, I'll just substitute 0 now, and over here we will get 0 plus 0 minus 2 by 3, because cos of 0 is 1, and rest of it will also be 0. So that leaves us with pi by 4 plus pi by 16 minus 2 by 3. That is pretty much left, and let's just simplify this. 2 into, let's just take LCM over here, and this will become 5 pi by 16 minus 2 by 3. And this just becomes 5 pi by 8 minus 4 by 3, and that will be our final answer. So the main gist here was to understand this part over here and this part over here, which was we first had to convert this into this, and then we had to recall that if For example, sine squared theta is equal to 1 minus cos 2 theta by 2. Then sine squared 2 theta will equal to 1 minus cos of 4 theta by 2. And sine squared, let's suppose sine squared 4 theta will equal to 1 minus cos of 8 theta by 2. So this is a law of trigonometry that you need to know in order to solve this integral right here. Thank you.